Hello and good day, geometry. We're moving on to, like I said, the only non-power objective of the unit, CO40, is the one you can afford not to pass without needing to retake it. And it's important, right? But it's not as important as the Pythagorean theorem itself or some of the other things that we'll be talking about shortly. Yes, sir?
Is there POs in high school?
Depends on where you go, but usually not. No.
Okay, so then why are we doing POs?
Because I just care about you. Yeah.
I know, but we're trying to prepare for high school.
Yes, that's true.
So
that's why
no
you have
POs.
that. It's like swimming lessons, man. I'm not going to move you on to the next level if it's just going to drown. So, in PO 39, we talked about the Pythagorean theorem. And the Pythagorean theorem states what? Yeah. Not right now, unless you really got to go, because this is the bulk of the lesson right here. Yeah. A squared plus B squared equals C squared. Now, if you remember talking about this, and I mentioned this, I actually wrote the converse of the Pythagorean theorem. And what is the converse of the Pythagorean theorem?
C squared.
Right? C squared equals A squared plus B squared. So the general theorem says that if A squared, or if it's a right triangle, then A squared plus B squared equals C squared. The reverse of that is going to have C squared first. And say that C squared will equal the sum of A squared plus B squared. Okay? And the reason why we can write it like this is because it's going to make theorem 7.3 and 7.4 a lot easier to understand. Because what happens if A squared plus B squared doesn't equal C squared? Okay? If A squared plus B squared doesn't equal C squared, you've got two other options. What are the other options if A squared plus B squared doesn't equal C squared, right? It could be an acute or obtuse triangle, right? If the triangle's not right, it's either, well, isosceles deals with side lengths here. This is the angles, right? If a triangle's not a right triangle, it has to be either acute or obtuse. How do you tell? Well, we can use the Pythagorean theorem, or the converse of it, and its related theorems, to help us. Because if C squared is less than A squared plus B squared, what type of triangle do you think we're talking about here? Acute, right? Because an acute angle is less than 90 degrees. That deserves a button right there. Okay? And the other option, if C squared isn't equal to A squared plus B squared, it's not less than A squared plus B squared, but instead C squared is greater than A squared plus B squared. What type of triangle do you suppose we have here? Obtuse. Okay? Now, and again, the reason why I'm putting that C squared first, and you don't have to write this down if you don't want to, because it just might confuse you, but C squared is less than A squared plus B squared is the same thing as saying A squared plus B squared is greater than C squared, which, because if you reverse the sides of your values, you have to reverse the inequality symbol. But looking at that, most people think, oh, obtuse, because greater than, right? Which makes sense. Your brain naturally goes there because an obtuse angle is greater than 90. But by putting that C squared value first, it helps align that less than acute and the greater than and the obtuse. Okay? So in your book or other places, you might very well see A squared plus B squared is less than C squared is an obtuse triangle. That's not wrong. It's because the C squared is on the other side of the inequality symbol. Okay? But what I want you to remember is when you calculate that C squared, if it's greater, obtuse. If it's less, acute. If it's equal, it's right. Those are your three options. Okay? Like I said, CO40 is nifty. It's not a PO worthy, but it's definitely worth talking about because, math is kind of neat like that. Okay? Questions so far before I delete the notes here? Any questions on what we have? Damien, turn around, please. Jack.
How many POs are
in this unit? You've got 39, 41, 42, 43, your algebra review, and your mixed review. Why'd I skip? 6. 6? What? Yes, Ellen.
So the only way to actually find the exact value of one of the lengths is if it's a right triangle.
Yes. So here's the thing. Ellen's kind of taking the next step here, which is brilliant. If you didn't know, if you had an acute or an obtuse triangle here, okay, and you didn't know a side length, could you use this theorem to help you find the side length? No. Okay. That's why we have the triangle inequality theorem, where we can figure out a range of what it could be. Like based on that, 20 minus 14 is 6. 20 plus 14 is 34. This third side is between 6 and 34. Okay. You can only use the Pythagorean theorem to solve for a missing side in a right triangle. Damien, I
said marry this year.
not now, man.
Well,
If it's a right triangle, but you can use an associated theorem just to tell you this is an obtuse triangle. But you need all three sides to do it. Okay, so these are not to solve for sides. This is just to tell you what type of triangle it is. Okay, Arlene.
So it's on problems that'll show you what the triangle looks like.
That, yep. Or if it's not drawn to scale, or if it looks like a right angle, but you're not quite sure. Rowan, turn around, please. Okay, that's when you use these here. Yes, yes. If you want to go down. Okay. All right. Let's practice a little bit.
yay.
Let's see. How do you know? Oh, this is a good point here. How do you know which values to use for A, B, and C? Recommend.
The largest angle is C and the
Longest side. Okay.
longest side.
We're not using angles here at all. These are all side lengths here, right? That we're trying to determine what type of angle it is. But yes, C has to be in the place of the hypotenuse. This is always the longest side. Again, if it's an acute or a obtuse triangle, it's not called the hypotenuse. But we have to, in case it is a right triangle, that longest side has to be in place of C. These other two are interchangeable. Okay? So 10, 11, and 14.
How do we do this?
Good question. Good thing I'm here today.
Oh,
Okay.
I got it.
So we basically want to figure out, this is our longest side. We know that is side C. We want to say, what's the relationship between 14 squared? I don't put a box here with a question mark because we don't know what the relationship is right now. We have to figure it out, right? But what's the relationship between 14 squared and 10 squared plus 11 squared? All right, Damien.
I'm gonna have to go with a cube.
How do you come up with that?
I put one of those big alligators going up to 10 and 11.
So what is the value of 14 squared? Let's start with that. 196.
Yep.
Okay. 10 squared is 100. 11 squared is 121.
Yeah.
That gives us 196 compared to 221. Okay. Damien's alligator looking thing, right? What goes inside the box? 196 is less than 221. So what type of triangle is this? It's an acute triangle.
What did I say?
You said acute.
Yeah, I sure did.
I didn't say you're wrong. I wasn't challenging you. I was showing people how you got that.
Yes.
Yeah. Good job. Okay. The next one. What's the longest side there? It's not always going to be the third side given, but what's the longest side here? Ellen? It is the 8. If you calculate 4 times root of 3, it's going to be less than 8. And so we're looking at 8 squared. And here's our mystery box. We don't know what goes inside there yet. Okay. We're looking at the relationship of 8 squared compared to 4 squared. And here's where you're going to make a mistake on the test if you do here. When you square the value of 4 root 3, what do you need to include? Parentheses. Because if you don't, if you use your calculator and just put 4 root 3 squared, what is your calculator going to square? The root 3 and only the root 3 because exponents comes before multiplication, right? So you need parentheses around the 4 root 3. Essentially, you're distributing this power into the 4 and into the root 3. Okay, 8.
Could you just turn the 4 root 3 into a decimal and have it that way?
Yes, that would also work. Just to make sure you don't round. Okay? Because if you round a decimal and square it, now you're using a slightly inaccurate value. Okay, so make sure that you use that answer function there. So I'm going to show a little more work on this. 8 squared, of course, is 64 there. 4 squared is 16. And what we get when we square 4 root 3, again, what we're doing is we're squaring the 4.
We multiply it.
And what is the root of 3 squared?
9.
The root of 9, which equals
3.
3. Remember last year we talked about what happens when you square something under the root? Roots and exponents are opposite operations, right? These cancel out. And so the root of 3 squared, if you multiply root 3 times itself, root 3 times root 3 gives you the root of 9, which equals 3, right? Essentially, the roots and the power just cancel out. But a lot of people forget about that coefficient 4. It's going to be 16 times 3. 64 is what compared to 16 plus 48? Okay? It's equal. So, what type of triangle is this?
Right.
Right.
The right triangle is an equilateral triangle.
What's that?
Whatever.
Okay. So, squaring roots can get a little bit tricky if you're not paying attention. Put those parentheses in there, or do it mentally. You can do this, okay? But just be aware of that. Damien.
When you do the multiplication, in the parentheses, do you do 4 times root?
You don't have to include the multiplication symbol,
Okay.
but you can if you want.
Okay, but it doesn't matter.
No. Just make sure you close your parentheses. Remember, when you put a root into a calculator, it gives you that first set. Make sure you close it. So if you were to put 4 root 3 in your calculator, it should look like this. 4 and then the root, and it gives you that first set of parentheses. Put in your 3, close that one, close the original one, and then square it. You actually have 2 sets in there. Yeah.
Wait, what?
Yeah. If you only close the first set, it still leaves this. If you only close what is in the root, it still leaves that open. Okay. Putting things into a calculator is a lot like grammar. You know, things have to be in a certain order. Things have to agree with each other. Okay. Very grammatical. You know what grammar is? Grammatical. Yeah. Yeah. All right, last one.
I got it.
13.8.
I got it.
Okay.
I got it.
What's the longest side here? 5, 6, or root 61? Root 61.
I have a question.
Yeah.
When I did it, I did 4. I did parentheses, 4, root 3, but it's automatically adding a parentheses. So I just do this.
I mentioned this, right?
Yeah.
Yeah. You have to close the parenthesis that it gives you, and then close the original one that you put in there.
Yeah, but how did I get 13?
Because you probably didn't close one of the parentheses.
I got 48 now.
There you go. All right, so squaring root 61. And we wouldn't need parentheses here because root 61 is an isolated term, but it doesn't help to get in the habit of it. We're looking for the relationship between the root of 61 squared and 5 squared plus 6 squared. Now, what's the root of 61 squared? 61, right? Roots, powers, opposite operations cancel out. Okay? So what's the relationship between 61 and 25 plus 36? 61 is equal to 61, therefore this one is also a right triangle. Okay? Questions on any of this? Yes, indeed you do.
I gotta be like that.
Why gotta be like that?
I gotta be like that.
Why have they give you opportunities to practice?
Yes.
Because
It's not an opportunity, it's fun.
Because
not punishment. I give you the number game.
we got the number for it.
Whose fault is that?
Not mine, so.
If I can find my geometry book. If I can't find my geometry book, then I guess.
I'm one of the only ones. Yes, you are. Rowan, it's me and you.
Catherine also didn't do it.
Will too.
Okay, your homework on page 444. Page 444. You are to do 15 through 23.
That's a lot.
It's 9 questions.
Give me a nine.
15 to 23. This is due tomorrow. That's how you math.
Don't forget to like, subscribe.